Okay, Lewis, so this is probably the most difficult part. It's probably the only difficult part in this chapter. And we're looking at mutually exclusive events and mutually inclusive events with regard to Venn diagrams. Well, let's look at the mutually exclusive events. Okay, so we said mutually exclusive events are when two events can't happen at the same time. So in this, if I don't know, if I choose A, well, I obviously can't choose B because no overlaps. So, and if I choose B, I can't choose A. So there's no choice here to actually make a choice and that choice giving me A and B at the same time, because they're exclusive. Okay? They're one is not overlapping the other. But over here, mutually inclusive. Well, I could choose A, I could choose B, but look at this bit in the middle here. I can choose A and B. So these events are mutually inclusive, meaning if I choose something in here, I can pick A and B at the same time. This over here is very easy. It's just like we've done already. So what's the probability of A and B? Well, probability of A multiplied by the probability of B. Okay. But over here now it's a little bit different. If I want to get A without B, so if I want to get the probability of this, okay, well, the probability of that is the probability of A and B together over the probability of B, or another way of saying it, the probability of A intersection B, which is this bit, over the probability of B, which is all of B. Okay, so I'm going to do that down here. So it's asking me to find the probability of A without B. So they're asking me to find the probability of this. Now I have the probability of all of A. Okay. And I have the probability of all of B. And I also have the probability of this bit here, which is A union B. And what I'm looking for is the probability of A without B, so this bit. Okay, so if we look up here, this is the formula, and we have to know that because it's not in our logbooks. So the probability of A B equals, now I'm going to look at this. Have I probability of A intersection B? I do. Okay. And then have I the probability of B, which is the whole lot? I do. Okay. And that will give me a probability of 0.16. So the chances of getting just this is 0.16. Okay. If we look here then, this time they're looking for us to get the probability of getting this, okay, which is A intersection B, which is the bit that includes A and B, both. If we look over here, probability of A intersection B is the probability of A multiplied by the probability of B without A. So, the probability of A equals, the probability of A intersection B equals the probability of all of A, which we have, multiplied by the probability of B without A. So this. So they're basically getting us to multiply all of that multiplied by just that. Okay? Because if we multiply all of that by all of that, well, we're actually double counting this. Okay? So we're multiplying all of that by just this bit. Okay? Just this bit. and we get 0.14. So 0.14 is there. Okay. I hope that makes sense, Lucy. Again, it's the only tricky enough bit in it, but go over the book and go over some of the questions. Any problems, make sure and email me. Okay. Okay. So the last bit, Lucy, we're looking at conditional probability. Okay. So I'm going to give you a scenario here, and we're going to work through it. We have 6 marbles. 2 of them are red, and 4 are green. And what we're going to do is we're going to choose a marble, okay, so randomly, okay, without looking at it. And then we're going to choose another marble. But in this case, when we choose the first marble, we're not going to put it back in. Okay? So let's try to get our head around this. So they're asking us in the first question, what are the chances of getting 2 reds? Okay, when we start off with 6 marbles, and the chances of getting a red, well, there's 2 out of 6. Okay, and okay, if you look at this, what are the chances of getting 2 reds? Well, that's the same as what's the chances of getting a red and a red. So that's our AND rule. Okay, so that's multiply. Okay, let's get this a bit better. No. So again, the chance of getting 2 reds. I know the AND word isn't there, but really, what is 2 reds? It's a red and another red. So here's the chances of getting the first red. But think about this. If we do pick out that red, it's gone. So what's the chances now of getting our second red? It's 1 out of 5, isn't it? Okay, and that's what conditional probability is. And remember our AND rule. There we go. And that will give us 2 out of 30, which is 1 out of 15. Okay, let's look at the second one. What are the chances of getting red and then a green? Okay, well, first of all, what's our chances of getting a red? Again, it's 2 out of 6. Okay, or we'll make it easy on ourselves. 1 out of 3. So a red and then a green. Now remember, we must have got the red first. So now we have 5 left, and our chances of getting green are 4 out of that 5. Okay, so chance of getting a red and then a green is 4 out of 15. Now the last one. What are the chances of getting a red and a green? Now that's different to this. This one here says what are the chances of getting a red, so a red first and then a green. Whereas this one says what's the chance of getting a red and a green. So it can be in any order. So we could get a red and then a green, or we could get a green and then a red. So we could get this or this. Right. Well, first of all, I'm going to find the chances of getting a red and a green. I've actually done it up here. Okay, the red and the green. So the red and the green is 4 out of 15. Now we'll get the chances of getting a green and a red. Well, a green, first of all, is 4 out of 6, or 2 out of 3. And, remember, and a red, so multiply. Now, if we got the green, we have 5 left, so it would be 2 out of 5. That makes sense. And again, we will get 4 out of 15. Okay. Now just have a think. That's our chances of getting a red and a green. That's our chances of getting a green or a red. We're asked what's the chances of getting a red and a green, but in any order. Okay, so if we get this or this, it'll satisfy this question. And look, or, so 4 out of 15 or 4 out of 15 should give me 8 out of 15. Okay, so I hope that explains it, Lewis. Okay, we'll talk to you during the week. Thank you.